In this video, we are going to be concluding the Unit 2 notes with Part 7, which covers phase changes and the heating curve for water. We're going to be starting off with a checkpoint related to what we were talking about in our previous video. When you first add heat to ice at 0 degrees Celsius, the temperature of the ice does not initially rise. What do you think happened to the heat energy? Now, when we're adding the heat to the ice, the energy is actually being used for some other process besides making the temperature increase. So you have to think to yourself, well, what is actually happening to the ice? We know that 0 degrees Celsius is the melting or freezing point, depending on the direction that you happen to be moving in. And for us, since we are adding heat, we would call that the melting point. So as I am adding heat to this ice and the ice is melting, the temperature is not changing. So the energy must be being used for that actual process. So the energy is needed in order to melt the ice. So this process is not exclusive to this particular phase change, going from a solid into a liquid. It would actually occur at any phase transition. So you're going to see constant temperatures at all phase transitions. Now, if we're talking about water specifically, like we are here, the other notable phase transition would be 100 degrees Celsius. That would be the evaporation or the condensation point, depending on what direction you're heating or cooling in. All right, in this diagram, we have each of the different phase transitions that could potentially occur. And 4 of them you should be pretty familiar with. We have melting or freezing when we're going between a solid or a liquid. We have evaporation and condensing when we go between a liquid and a gas. And the 2 that are less common that you don't see very often are deposition and sublimation. So deposition would be when you're going from a gas directly to a solid. And a good example of the deposition would be in the winter when you have frost which forms on your lawn. So you have water vapor, which is skipping the liquid phase and going directly into the solid phase. Next, you have sublimation. So when you're going from a solid directly to a gas, a good example of this would be dry ice. So dry ice is frozen carbon dioxide, and if you let that sit out, it's going to go directly back into a gas and it's going to skip the liquid phase. So these are 6 terms for phase changes. A heating curve is a graph of temperature versus time for a substance as energy is added to a closed system at a constant rate. We now know that during phase changes, the energy that would typically be used to increase the temperature is instead put towards achieving a phase change. So that's what we had on our first slide with our checkpoint. We know that the temperature is going to be constant whenever we are melting or freezing or condensing or evaporating. In this next checkpoint, we are going to be filling in a heating curve for water. We are going to assume that water starts out as ice and it is constantly heated. Now you can see that for our y-axis, we have our temperatures filled in here, but for our x-axis, we just have time listed. So no specific intervals here with no specific minutes, and that was done on purpose. Now we're going to start off with negative 40 degrees at our initial time. So we're going to start off here. And I know that as I add heat over time, the temperature is going to increase. So my temperature is going up. But at some point, it's going to stop increasing. From that first checkpoint, we learned that at a phase transition, the temperature is going to be constant as the ice is melting. So how would that be represented on a graph? Well, that would be a straight line. So our temperature is going to plateau. Now, we don't know exactly how long it's going to plateau for because that is dependent on how much ice we're starting with. It's going to take a lot longer to melt, say, a glacier as opposed to an ice cube. But let's say over some set amount of time, so I'll draw it out to here. Now everything is going to be in the liquid state. Now the temperature can start increasing again. So I'm going to start increasing my temperature until I hit another phase transition. And that next phase transition is going to occur at 100 degrees Celsius. Now once I get to 100 degrees Celsius, now my water is going to be evaporating. So that means I'm going to need another plateau until all of that liquid water has turned into a gas. It's turned into steam. Now, once my steam is fully formed, there's no more liquid water. At that point, the temperature can continue to increase well beyond the 100 degrees Celsius. So we'll continue going up from there. So this right here is what you would expect for a heating curve for water. Now on our next slide, I have another version of this, which just has a few terms filled in. So anytime that we have a slope which is increasing, we have a specific phase of matter. So here I have a solid, a liquid, or a gas. Anytime we have a straight line going across, so our plateaus, that's going to be a phase transition. So here I could say that I have both a solid and a liquid, and here both a liquid and a gas. But if I ask for the actual transition, I would say this is either melting or freezing. This is either vaporization or evaporation, or condensation. So this is our heating curve for water. So on your assessment, you're going to be expected to be able to interpret this. So in the past, I've had students either draw this and then they have to explain what the different parts are, or maybe I give you a picture without each of these words filled in and you might have to identify parts of it. All right, that concludes the notes for Unit 2. These are all of the topics which have been covered within each of the videos. And before we end completely, I just wanted to go over a couple more things. So resources that you have access to. Remember that within Unit 2, you have been assigned a variety of key assignments, and these questions are going to be found either exactly or very similar to the ones that are going to be on your unit test. So you want to make sure that you complete each of those assignments and that you can continue to submit each of the ones that you can get up to an 80% on so that you can improve your grade in real time. For our labs, in this unit we typically do the separation of a mixture lab. If we completed that lab or any other lab, make sure that you look over those before you have your assessment. And if you have any questions, make sure that you ask them. And finally, your resource would be our YouTube channel. We know that in addition to the videos that I post, there are a number of videos from other sources. So for Unit 2, you have the video from the Royal Chemistry Society, which is on the alkali metals. And you also have videos from TED Ed, which you could watch.